Welcome to InsideAM, a podcast series brought to you by NDT specialist Theta Technologies. Here's what to expect from this episode.
We consider ourselves as a world-class advanced manufacturing research center delivering results in different areas. We're trying to actually close the gap between the university level research, which has low technology readiness level, and industrial applications.
The numbers of women in this industry is increasing. What do you think is starting to lead to that increase?
It starts from very early ages, from primary school. We know that boys are always more interested in science, in engineering than girls, and I think we have to find solutions to change that. And we all have responsibility in that field in order to increase the adoption of AM as well.
That level of speed, was that only achievable with AM?
I think one of the key drivers is that we have very high complexity that can't be achieved by other technologies, but also the lead time from design to testing is quite reduced in additive manufacturing. I think qualification stays as the main challenge for wider adoption of AM technologies.
We're back with another episode of InsideAM, a podcast brought to you by Theta Technologies. Today we've travelled up north, northwest specifically. I'm here at the AMRC and I'm thrilled to have Evren Yasa with me.
Thank you very
Evren,
much.
thank you for taking the time out of your busy schedule to join us for this podcast.
It's a pleasure.
Let's first of all just talk about you here at the AMRC. Just give us a bit about your background and kind of what led you to the AMRC.
Sure. So I have been working as the head of AM in AMRC since 2022. So it's been 2 years that I'm in this role. AMRC is a part of University of Sheffield, and I'm specifically located in AMRC Northwest, which is in Preston. And my background is I'm a mechanical engineer, and I did my PhD in additive manufacturing. And after my PhD, I worked in industry, in aerospace, in a G joint venture company. And I also work at the university as an assistant professor. So I have been working as an independent expert for the European Commission in the last 2 years, 10 years as well. So I have been in additive since 2005. So it's been almost 20 years now.
Wow, 20 years in additive manufacturing. You must have changed quite considerably over that time.
Yes.
Which hopefully we'll cover in this podcast. But what led you to the AMRC? How did you end up here?
AMRC is I would say in Turkey it's a very well-known research center. It's I think inspiring place for many research centers in the world and also in Turkey. So when I saw the post on Head of AM, I thought it's my dream job. So that's why I applied to it, and luckily I got the position.
And your role here, what does that encapsulate? And you've been here 2 years?
Yes, that's right.
What's been your highlight in those 2 years here at the AMRC?
So I have been in this role for the last 2 years, and I'm leading now a team which has 18 engineers, very competent and very experienced individuals. And I'm also leading all AM activities and projects in AMRC across different groups as well. And the highlight of AMRC, from my experience in the last 2 years, I would say it's very dynamic. So no 2 days are the same. It's always you end up with different projects, different applications, different challenges, which is good for us. And it's also I would say, working on innovative projects, innovative solutions. It's also inspiring in terms of your individual development.
And so you've been kind of getting about a bit really in the AM industry at the moment. Recently we've just had the TCT event. Yeah. You were down there as part of a panel talking about women in 3D printing. Yeah. If you don't mind, we'll talk a bit about women in not just 3D printing, but in engineering as well. Okay. Firstly, down at TCT, what were the types of discussions happening around women in 3D printing and engineering?
Yeah, actually it was a panel consisting of women in 3D printing, but the topics we discussed more were on the opportunities and biggest challenges in additive manufacturing and how to overcome those, the biggest challenges as qualification and gap skills, how we should be working towards those challenges. And I think regarding how to involve more women in 3D printing, I think it starts from very early ages, from primary school. We know that boys are always more interested in science, in engineering than girls. And I think we have to find solutions to change that. And we know that in the last 15 years in the UK and also in the world, the number of women in engineering has been increasing. But it's mainly not in the core engineering roles, I would say. So we should work on the best practices and like in recruitment, in retention of these women engineers, more in the core engineering roles, how to do that. I think that's the key to increase the presence of women in 3D printing.
And you mentioned there that it is the numbers of women in
Yeah.
this industry is increasing. What do you think is starting to lead to that increase in women getting involved?
I think it's not only in 3D printing. I think generally the presence of women in engineering has increased. It's not only in one specific domain, but it's more, I think, this STEM kind of programs in high schools, in secondary schools, I think they work as well. But specifically for 3D printing, I think it's very interesting in terms of creating items that you have designed, for example. It's interesting to boys and girls, and specifically you can just design anything that you like. So that's also more, I think, appealing for girls in that field. So I think with polymer 3D printing especially, I think we can take interest, we can just involve more girls at earlier ages. So, but I'm not sure to what extent it's done at the moment. We should be more active in early stage programs, as I say, like starting at primary schools.
And did your personal experiences, did you ever feel like, as a female trying to enter this sort of industry, did you ever feel like there was any sort of barrier at all?
There are always barriers for women in engineering. I would say it's always more difficult. You have to do more efforts to survive. But like not recently, I would say. After I finished my PhD and after I started working in this industry, I haven't encountered anything specific that I can name. But in a male-dominant industry, it's always difficult to be a female engineer. So, yeah.
What would be so let's just say any like young girls watching this that perhaps wanted to pursue some sort of career, 3D printing, engineering, would you have any advice for them about how they kind of go about that if they're not getting that fundamental, that earlier stage education in that industry? What would be your advice?
I think it's a more general advice I would have. It's more like people should find what they like doing, because it's a job that you do for your like at least 30, 40 years of your life. So if it's not something that you enjoy doing every day, that would be quite like pain. So that's why I would say they should explore different things and find what they are good at, what they like doing. So I think that would be the best advice. And 3D printing, additive manufacturing is a good area because you have a different variety of like skills, core competencies like design, manufacturing, post-processing. So it's quite a wide range of skills that you would need. So one part may be interesting than the other, more interesting than the other one. So it's good to explore and like try different things to find what you're good at and what you like to do.
Let's talk about the AMRC and how you operate.
Yeah.
How does the AMRC operate? What's it trying to achieve?
Sure. So AMRC is a part of the University of Sheffield, and it was established in 2001 as a collaboration between Boeing and the University of Sheffield. So we consider ourselves as a like world-class advanced manufacturing research center delivering results in different areas like machining, casting, composites, training, testing, and also additive manufacturing. So we're trying to actually close the gap between the university level research, which has low technology readiness level, and industrial applications to avoid the value of that for good ideas. So if an idea is good for an application, it shouldn't stay at a very low TRL. So AMRC is taking our building on that new idea and helping industry to bring into a commercial application. So that's where we're trying to cover. And it's very important for us to know actually that the industry is interested in what we are doing. So there's always an industrial pull in the research that we are doing.
And when it comes to connecting RTOs with the wider industry, what role does the AMRC play in that?
So regarding RTOs, we are also a part of research and technical organization, I would say. So we're also working with different universities, with different RTOs, and also industry. So depending on the area and expertise that we would need, actually, we work with everyone with whom we can collaborate and deliver higher impact. So the major outcome that we're looking for is the impact that we create. It can be the number of jobs that we create, or it can be higher productivity or lower environmental impact, but we're always after creating the impact for our customers, for our partners. So that's why we try to work with different universities as well. In the AM field, we have worked with University of Sydney from Australia. We worked with University of Southampton and University of Huddersfield, for example, from the UK. And we also try to disseminate the collaboration in scientific journals and conference proceedings. So in the last 2 years, we have published more than 20 papers in the AM only with the collaboration we're doing with different universities. What about noise here?
Don't worry, it'll be fine.
Okay, sorry.
Should say we're in a working environment, so yeah, if you hear any strange background noises, that's what's going on.
Okay.
In terms of, so talking about working with different industries and different universities, things like that, one recent project that kind of stood out was the rocket motor testing.
Yes.
How did that come up? We were talking about this before we actually started recording, and how significant this actually was.
Sure. Actually, space is one of the very interesting areas of application areas of additive manufacturing. And the requirements are not the same as the other industries, so it's always more challenging. And actually, the geometrical complexities that we need to achieve in space are always more difficult. So we also have like requirements because these parts will function in very harsh environments. Therefore, it's always like challenging and more interesting to work in space applications. So this opportunity came from our space engagement manager, which is Yun Cho, and he was directly contacted by the rocket team of the Kingston University. So they needed these two main parts of the rocket to be able to hot fire test it in 2 weeks' time. So it was a little bit like challenging for us because of this tight schedule. And I think in the end it was like it was a world record that we broke all together. So actually it was like contribution. There were contributions from many different people to this challenging project, and everyone did their best to be able to experimentally test the rocket in the end. So I would say my team at AMRC, they also did a great job. We work around the clock, so they came like in the middle of the night to top off the machine with the powder so that we can finish the builds. And in the end, it was successful, so we did the hot fire testing as well, so everyone was happy. But it was like, I would say, very exciting and fantastic to be a part of this journey, but it wasn't stress-free in the last 2 weeks, I would say.
I think when we were talking about this before, was it something like 2 weeks from conception to...
Actually, the design was already there when the project came to us. So they already had the design, but we had to do the pre-processing, like designing the supports, the orientation, etc. And I think what made it worse, like we didn't have the powder in stock, so we had to buy the powder in 2 weeks as well. And we built the parts in like more than 6 days. So taking everything into account, it was like a miracle in the end.
Was that level of speed, was that only achievable with AM?
I think so, yeah, that there is no other, because the complexity of the parts was too high. It wasn't possible to make it with any other technology. And also, I think the AM's speed in like from design to testing helped us a lot here to make it happen.
And in terms of space as an industry in general, the adoption of AM is, what are the main reasons why spaceflight applications, they're kind of starting to go down that route of additive manufacturing? You mentioned complex parts there. Definitely. Is that the key driver in this?
I think one of the key drivers is like that we have very high complexity that can't be achieved by other technologies, but also the lead time from design to testing is quite reduced in additive manufacturing. If you want to go with other technologies, it will take time to make the dies, molds if you need, or special tools that you would need for machining, etc. So it's always the lead time, the reduced lead time, and also the material efficiency that we have here, because generally with aerospace, the high buy to fly ratios is a problem, and the waste material is always very expensive. So using AM technologies, we can reduce the waste material. So that's why I think additive manufacturing is very advantageous. But for other sectors, like medical, for example, customization is the main lead there, because anatomically, humans are different from each other, and we need different hip implants, different like dental crowns. So it's the customization that would lead the applications in medical.
Okay. There's a bit of an elephant in the room, though, in terms of actually adopting AM, and this is still a constant theme. We talked about this again before we started recording. The inevitable qualification of those parts when you're producing parts for space flight, for medical,
For
real
anything.
critical applications. There's still a big issue when it comes to the qualification of those parts, isn't there?
Yeah, definitely. I think qualification stays as the main challenge for wider adoption of AM technologies. It's not only because we lack qualification tools, standards, and methodologies to qualify AM parts other than mainly CT scanning, but it's also the processes are not fully reliable so that we are sure about the quality that we will get every time. So that's one of the aspects at AMRC we're trying to improve in terms of the AM processes, like the reliability, but also productivity and accuracy of AM process need to be increased so that we have a wider adoption in different industries.
So actually, it's not, when it comes to inspection, it's not actually arguably the inspections, but actually streamlining that process with AM and actually making sure that the build is consistent. Is that part of the problem?
I think so. I think it's not only that. Most of the time we talk about the lack of standards, lack of qualification methods, tools. Yes, they're also they need to be developed at the same time, but it's also the robustness of the processes, AM processes themselves, that we need to address.
It'd be rude not to talk about NLR, nonlinear resonance theta. You've had experience. You've actually had RD1 here for a project a few years ago. It was very early on in the stages of the project there. What were your impressions about, certainly when it comes to part inspection and where this can fill a gap for qualification with AM?
Yeah, I think we were quite lucky to have the equipment here for a while, and it was a project that we had carried out with BAE Systems and Theta Technologies. So it was a great experience. I would say it's quite, innovative solution for solving qualification problems in additive manufacturing in a fast and reliable manner. But as you say, it was very early in the development phase. So, but I think it's very innovative solution, and also something that we need really in additive manufacturing. So we need quick methodologies to qualify parts, and I think this technology is really very helpful in that sense.
Let's talk about AM in general. Again, it's kind of been a constant theme within these podcasts, actually, this kind of lack of knowledge, lack of confidence.
Yeah.
We've just talked about part qualification there. That confidence is only going to be come through the qualification of those parts. But let's talk about where AM can actually, for those that are using traditional manufacturing methods, where can AM actually help businesses move forward?
Yeah, I think this again comes back to the advantages of additive manufacturing, where we can benefit from AM. I think first of all, the lack of knowledge is quite a barrier there. So the companies, I think we're talking about a wide spectrum of companies, especially in the UK. So at one end of the spectrum, we have large companies who know about AM, who have already invested in additive manufacturing, and they make use of AM. But on the other end of the spectrum, we have mostly small and medium-scale companies, SMEs, which want to explore additive manufacturing, but they don't have enough knowledge. So I think it's very important to direct those companies in the right direction so that they know how they can benefit from AM rather than just experimenting with additive manufacturing. Because sometimes it also leads to a misconception that it doesn't work at all. So I would say, depending on the application area, customization, geometrical complexity, lightweighting, or if you want to buy just one of a part or very low volume production, then additive manufacturing may be your solution. And also on-demand manufacturing for bespoke parts, for example. Or if you want to deploy AM technologies for in-theater repairs, for example, it's always beneficial to look at the specific advantage that AM would give you. But if you're just trying to replace and machining parts with additive manufacturing, if you're just directly trying to replace that, additive manufacturing will not be cost effective in that application. It should be always giving you some added functionalities. Otherwise, I think AM will always, or at the moment at least, is more expensive than other manufacturing technologies.
Are you still finding that where actually companies are trying to use AM for parts that have no real reason to be?
Sometimes. It's less now, I would say. 5 years ago, 10 years ago, it was mostly companies were looking for just replacements. But now I think when they come to us, they want to, for example, have at least like topology optimization so that we can do lightweighting. But still, some companies are just trying to evaluate or assess the AM technology's feasibility based on existing part geometries. So I always say it upfront. We don't need to do this. It will be always like machining will win here because this part is better to be machined rather than AM.
Where do you think that knowledge comes from? Is it organisations like the AMRC? Is it your responsibility to kind of make sure that...
Yes, I think so. I think like as research centers, we have that responsibility to increase the knowledge in industry in terms of additive manufacturing. And we have dedicated programs, and we also work on like bespoke training modules depending on the needs of the customers. But it's our responsibility to educate people, SMEs, companies in this field. Yes, definitely.
So despite the challenges when it comes to part inspection, knowledge gaps, things like that, are you seeing increased adoption in AM? Is it moving forward as fast as you expected, or is it still slow on the uptake?
I think there is still adoption of AM technologies, and the growth of AM is visible in like Waller's report, etc. So we see that it's still increasing, but I think now it's more solid. It's not like just, if you look at the Gartner hype cycle, I think we have exceeded the peak of inflated expectations now, and we are more on the, we're looking at more realistic and useful applications on the plateau of enlightenment or slope of enlightenment at the moment. So I think their applications are creating higher impact than previous, and they are more realistic. They are like going into serial production at the same time. But yes, it's not as fast as it could be, but I think this is natural with all new technologies.
Can we just end by talking a bit about sustainability?
Sure.
Obviously, the increased adoption in AM. There's pressures globally, commercially, about adopting more sustainable practices. Yep. Where does AM fit into that more sustainable manufacturing, more responsible manufacturing, or can it?
Yeah, additive manufacturing is inherently considered as sustainable because like the main advantages of reduced waste material, etc., it leads to the conclusion that it's inherently sustainable. But when you do use cases, when you do like compare additive manufacturing with different methodologies, you see that how sustainable AM is depends heavily on which applications we're talking about, which complexities, and also which materials and processes we're talking about. So I would say it's not always inherently sustainable. It will heavily depend on the application. But yes, with the reduced lead time, with the reduced waste material, increased productivity, AM can be very like good in terms of more sustainable manufacturing. But that will depend on like the use of materials. For example, if you go for titanium, it's most of the cases more sustainable. But if you're doing a part in aluminum, which is easy to machine, for example, it may be possible that it's not as sustainable as using traditional methods. So I would say there is no certain rules about it, but the main advantages of AM help us to think that it's always more sustainable, but it should be evaluated on a case-by-case condition.
And when you're talking to customers, are you finding that sustainability is at the forefront of their minds now? Does that come up in conversation?
I think so. It's always like sustainability is assessed. Even if we apply for grants, for funding, it's always an important factor to consider. So I would say, yes, sustainability is also something that our partners are considering in their evaluations or assessing whether AM is feasible. At least we can say AM is not making it worse, but still, if it's making it better, I think that's a reason to go for AM process as well. But of course, it should be cost effective at the same time.
This podcast has been developed as an educational and informative resource that delves deep into the world of additive manufacturing with experiences from those individuals making it happen. If you've got a story you think those working in AM should know, feel free to reach out to our team. To stay up to date with our latest episodes, make sure you subscribe to our YouTube channel and connect with us on LinkedIn at Theta Technologies Limited. See you next time.